Today we are going to talk about VMware Tanzu Application Service and how it can be extended with a cloud service broker for AWS. My name is Nick Kuhn, and I'm a technical marketing architect at VMware working on the Tanzu Application Service platform. The main question we are trying to solve is how can Tanzu Application Service enable developers to easily consume AWS services? The Cloud Service Broker for AWS is here to help. With the Cloud Service Broker for AWS, developers can directly consume AWS services and integrate them into their code from the Tanzu Application Service Marketplace via the Apps Manager or the CLI. This enables your developers to spend more time writing code and less time dealing with tickets. The broker puts IT and platform ops in control of all the things. IAM roles, VPC config, AWS credentials, AWS service offerings are all controlled by operations and can be molded into your organizational guardrails. There's no need to grant everyone access to the AWS console. Existing Tanzu Application Service RBAC config can be used to control who gets access and who does not. Chargeback or showback are achieved through automated tagging of services by the Cloud Service Broker on provision time. In our demo today, I'm going to show you how to use the Cloud Service Broker with the following steps. Step 1, we're going to use the Cloud Service Broker for AWS to deploy an RDS database instance directly from the Tanzu Application Service Marketplace. Step 2, we will then take an existing Spring Music application running on Tanzu Application Service and bind it to the database we deployed. Step 3, we will show the Spring Music application reading and writing from the database. Enough slides, let's get to the demo. As you can see here, I am logged into the Apps Manager, which is the main interface for the Tanzu Application Service. Let's drill into the Marketplace tab. There are many Amazon service offerings to choose from. I'm going to select the Amazon RDS PostgreSQL service offering. I'm going to select the mini plan. We're going to provide the service instance with a name and pass some advanced parameters to the broker via a JSON block. Inside the JSON block, I have two fields identified. Publicly accessible equals true to allow our lab to talk to the RDS instance over the internet. That's not typical for a production environment, as a more advanced network architecture would make use of VPC peering and direct connect. Instance name is also passed, which is the same name defined in Tanzu Application Service. This will allow for easy tracking of the RDS instance in both systems. Let's click Create. Now that the service instance is creating, the broker is talking to the Amazon APIs to fire up the RDS instance on our behalf. Let's take a quick pause while this instance creates. Now that the provisioning is completed, let's check the AWS RDS Console to see how the database looks on that end. You can see it has been created and has the same instance name that we provided via the broker. Let's drill back over to the Apps Manager and check out our application. I have already deployed a classic Spring Boot app known as Spring Music to the platform. We will use this app to connect to our RDS instance. If we drill down into the Spring config, you can see that the application is currently running from an in-memory H2 database, meaning that there is no real data persistence, as all data will be lost when the application gets shut down or crashes. If we flip over to the app route, we can see that the application starts with some default music albums. Let's go ahead and add a new demo album, knowing that we will lose this album if we restart the application. We're going to use demo for all the fields and click OK. Let's scroll down to confirm that the demo album loaded. Let's go back to the app view and we can drill down into the services tab in the Apps Manager. I'm going to bind an existing service to our application as we have already deployed our RDS instance. On the service dropdown, I'm going to select AWS Spring Demo 001 as that is the instance name that we provided. Let's click Bind. During the binding process, the broker is getting credentials for our application from AWS and securely storing them in CredHub, which is the credential management store in Tanzu Application Service. CredHub will then map these credentials directly to the application, and the Spring Boot framework will then take care of mapping them correctly. Now that the RDS instance is bound to our app, all we need to do is restart our application for it to pick up the new database connection information. Let's restart the app. Okay, the application has been restarted. Now let's check the Spring information again. As you can see, the application is no longer using the H2 connection string, but now using the Postgres connection type. Let's flip back over to the app route. You can see our original demo album is gone as it was lost when the application was restarted. Let's add a new Demo 2 album and confirm it's there. Now let's go back to Apps Manager and restart our application once more. If we go back to the app route, we should now see that the Demo 2 application survived the restart as it was loaded from the persistent AWS RDS instance. In summary, we deployed an Amazon RDS PostgreSQL instance with the cloud service broker for AWS. The broker was then able to bind the database instance to our Spring Music application. Our Spring Music application was able to read and write from the database. Furthermore, these steps show how the combination of Tanzu Application Service and the cloud service broker for AWS enables developers to easily consume AWS services. Thank you. If you'd like more information on Tanzu Application Service or the cloud service broker for AWS, please visit tanzu.vmware.com.